PreCalc takes a step up from Algebra 2. Because in Algebra 2, if you didn't know how to begin factoring, you couldn't factor. So if grouping didn't work, that was fine. You could get around that because they'd tell you, start factoring given the fact that x minus 3 is a factor. And then you would do long division to divide it out, and you'd factor that way. So this is a little bit different because they're not going to give you something to kind of kickstart the process. And there's a theorem that tells you what the possible rational zeros are. So there's lots of different types of zeros or roots. You can have irrational roots, which usually require the quadratic formula to figure out. You'd get like 5 plus or minus root 3 over 7. Those would be 2 irrational roots. Rational roots are ones that are nice numbers, like a half or 7. Whole numbers or fractions, right, for rationals. And then the third type of root that you have seen, well, you don't actually see them, but you know they're there, are imaginary roots. So this theorem here, what this is going to do, and I'm going to save you from reading that description because that's not going to mean anything to you. This theorem gives us all the possible rational roots. And we're going to get like 5 possibilities, 10 possibilities. That doesn't mean all 5 of them are actually rational roots. It's just that those are your only possibilities. So hopefully at least 1 or 2 of the 5 are actually rational roots. And here's where your possibilities come from. There's things, you'll hear me say a lot, find your p's over q's. Your p are your factors of the constant, which in this case, what's the constant of this first polynomial? What's the constant in this polynomial? 2. No, that's the leading coefficient. Negative 6. So the factors of that are 1, 6, 2, and 3. Over your q's, which are the factors of your leading coefficient, which was what, Ryan? 2. And the factors of 2 are just 1 and 2. So it's any combination of those. So if you were to actually list them out, you'd have 1 over 1, which is 1, or 1 over 2, which is a half. You'd have 6 over 1, which is 6, or 6 over 2, which is 3. 2 over 1 is 2, and 2 over 2 is 1, but we don't have to relist that because that's already on our list. Do you follow that? 3 over 1 is 3. That's already on your list. And 3 over 2 is 3 halves. So in this particular case, it looks like we have 1, 2, 3, 4, 5, 6 possible rational roots. We actually have 12 because you have plus or minus. You have 12. You have 12 possibilities. Now, of those 12 possibilities, there's no way all 12 of them are actually going to be rational roots, because how many roots does this function have to begin with? Max of 3. So at maximum, 3 of those are going to work, and 9 of them will not. But if there are any rational roots, they have to be on this list. Does that make sense? Yes.
So like if you go through and you find 3 of them, then you're just done?
No, we have to find which of those 12 actually work. And this is where you do synthetic division, because long division to test all 12 of these would be horrific. And the reality is we're probably not even going to have to do 12 rounds of synthetic division. You just have to do synthetic division until you find the first one.
Are we allowed to just plug in the calculator?
In an open response question where it doesn't specify your p's over your q's, you can do that. Because that's what you would have done in Algebra 2 because you didn't know this. You would have just typed it into your calculator, you would have looked for a root, and you would have grabbed that root, you would have known it was a factor, you would have done long division to divide it out. I'm not gonna, I know you have your calculator, so I'm not gonna tell you that you couldn't at least write your list out. Now, normally in advanced pre-calc, they don't have any calculators, and at some point, you won't have calculators on SATs. This probably would never be on your SATs, but at some point, you can get your calculator stripped from you, and you would just have to blindly start doing synthetic division. Maybe first with 1, and if that doesn't work, and what do I mean by it doesn't work? How are you going to know if it does work versus it doesn't work?
You have 0 versus remainder.
Right, 0 is remainder. So if you do synthetic division with 1, and you get a random remainder that's not 0, that didn't work, so you're done testing 1, then test negative 1. I always save my fractional testing till the end, because I just pray that it's a whole number, because it makes your life easier. So I always actually go smallest to biggest with whole numbers, 1, 2, 3. I'd get rid of negative 1, negative 2, negative 3, 2. So as long as you have your list down, I can't prevent you, nor can I know whether or not you typed it into your calculator and figured out which one it was, or it might be that all 3 of them are rational. So if I graph this and steal one of these roots, 1 looks like it works, right? So I would just pretend like I didn't use my calculator to cheat right there, and I would synthetically divide out 1, because you have to do the division. I'll show you why in a minute. So if I synthetically divide out 1, 2, 11, negative 7, negative 6, do that on your own for a second. So now that I found one that worked, what is this? 2 what? X squared. It was originally an x cubed, so that puts it down to a 2x squared of 13x plus a 6, and I factored out what? If I have a 1 there, what was the factor? X minus 1. So I essentially just factored it in that way, and then once you get it down to a quadratic, you can factor the rest of it or solve the rest of it by hand, depending on if it's solve or just find the zeros. Finding the zeros does mean solve. So I can solve this by teeing it up. I get x equals 1. That's one solution. And the other one, I can either do the quadratic formula or I can keep factoring. And I think I can guess and check. 6 and 1. That'll give me plus 12 plus 1. So my other 2 answers are what? Are those other 2 answers, that negative 1/2 and negative 6, are those rational, irrational, or imaginary numbers? They're rational. So they should have been on our list, and if you look, they were negative 1/2, negative 6. Would have taken me a while to test to get to them. But the reality of the testing, at least for like when I teach this to my advanced kids that have no calculator at all, is that once you find one that works, especially if it starts off as a cubic polynomial, that immediately will drag it down to a quadratic, and then you're done. Because the quadratic, you can always just ditch this whole method and do your old way. If it was a 4th degree polynomial, they would have to find 2 of them that work and kind of knock the 4th degree down to a 3rd degree and then the 3rd degree down to a 2nd degree, and then they'd be able to do it the rest of the way. Does that make sense? So we found the zeros. So on, like, back to Ryan's question about can't we just do this on the calculator, it's going to say find the zeros using your P's over Q method, or using, it'll probably say more properly, using the rational zeros theorem. So make sure when you hear rational zeros theorem, you know what that is. Okay. So come up with your list first. Mike, what are your P's? Your P's are your factors of the constant. What's the constant in this polynomial? the constant number is 16, so what are the factors of 16? Yep. 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 Yep, he didn't say 1 because I already had it written down. But 1 and 16, 2 and 8, 4 and 4. You don't repeat the 4. And then what are your Q's? Madeline. Okay, bring you back to the top. The Q's are your factors of your leading coefficient. Here the leading coefficient was 2. What's the leading coefficient in this problem? 1. So what are the factors of 1? 1. So this is nice because I don't really have any fractions that are going to come up. I have 1 over 1, 4 over 1, 2 over 1, 8 over 1, and 16 over 1, and then I have the plus or minus. So, shall we cheat again? Yes. No one will know. Let me see. Oh, good point. Does anyone know, just by looking at it, why he's not able to graph and it's giving him an error? Come on, Tori. Are you the only person in here that I had last year right now? You are. Correct. Someone who used this calculator last has a scatter plot turned on. And so if that's highlighted, a lot of times that'll interfere with your graph. Now you're fine. Good? So what is that root? -1. There's another one over here, but we'll just start with -1. So synthetically divide out -1. And now I want you, at this point, it's always a good time to pause and write down how you've so far factored this. So Maya, what factor would I put out here that came from the -1? X plus 1. And can you give me what would be the longer polynomial? Good. Now, if you can group that 4 terms, you can do that. But most of the time, I'm going to be honest with you, I don't think it's groupable. So then you would just keep going with your synthetic division testing. Here's the thing that I always warn kids out about, especially when they don't have a calculator, and this particular problem will kind of show us exactly why this is the warning. If you found -1 and it worked, first of all, you're going to pick up your synthetic division, dividing not out of the original, but out of this remaining piece. And if -1 just worked, you want to continue your testing with -1 again. Because it's possible, always, that whatever root you found is actually a double root. Does that make sense? And if you just move on past -1, you won't realize that, oh, it was a double root. And you guys should know from Algebra 2, just from looking at this, based on the fact that it bounces, you guys should know that that actually is going to be a double root, right? So -1, even though I just tested it, since it worked, I'm going to test it again, not in the original. I'm done with the original. I've already broken it down to a cubic, and I'm going to take advantage of that. So that's going to be 1, -7, 8, and 16. And just show that that works. So here's where my 4th degree went down to a 3rd degree. And now my 3rd degree is going down to a 2nd degree. So that's going to be x squared minus 8x plus 16. And then I have this x plus 1 plus my original x plus 1. And then that remaining quadratic can be done by hand. That's just x minus 4. So how many roots was I expecting?
3. Oh, 4.
4. And I don't have 4, I only have 2, but all 4 are accounted for, right? Because the negative 1 is a double, and the negative 4 is or the positive 4 rather, is a double. So 2 and 2 makes 4. Except for if you ask my child, he'll tell you that 2 plus 2 is 3 or something. It's not there yet. Poor guy. So your zeros to actually, so there's 2 ways they can ask this. They can say factor, in which case this would be our answer. Or they can say what are the solutions, what are the x-intercepts, what are the zeros, in which case our answers are negative 1 and 4. Just make sure you answer the question. Don't give me factors if they're asking for zeros, and don't give me zeros if they're asking you to factor. Okay, last one. How many roots are we expecting? 3. They don't all have to be rational, but we're going to come up with our list of possibilities. So, Faith, what are my P's? We'll just do 1 for now. I'll put my plus or minus at the end. And what are my Q's? Just 1. So yeah, you're right. Plus or minus 1 are my only 2 possibilities. So either something is a double root or a triple root, or maybe only one of those is a solution or is a 0, and the other 2 roots come from maybe irrationals or imaginary. So I'm just going to randomly pick to test 1. And it worked. So right here, Laura, what are my factors? Perfect. And is my remaining quadratic, by the way, I didn't cheat and use my calculator there, I just got lucky and I picked the right one. Because negative 1 would have failed me. Are you with me on that?
It did fail.
Did you check negative 1? It would have failed because I can already tell my remaining quadratic is not factorable. So if I want to tee this up and find the zeros, I have one of them, x equals 1. If I tee this up and want to find the zeros, I just have to do the quadratic formula. And if I have to do the quadratic formula because something's not factorable, then most certainly the remaining 2 factors are either going to be irrational or imaginary. They're not going to be rational. Rational things are factorable. So from my quadratic formula, the opposite of b is 4. Plus or minus the square root of b squared in this case is what, Alyssa? What number? But once I square b, what will it be? 16 minus 4ac all over 2a, which is 2. So what number comes from underneath my radical? 12, which is otherwise known as starts with a D. Good, discriminant. And then I'm going to break down root 12 into what? Right, root 4, root 3, which is 2 root 3. And then, can we divide both of those terms by 2? Yes, so I get 2 plus or minus root 3. So I have 1 rational root and 2 irrational roots. So all 3 are accounted for, right? I had a cubic polynomial. All 3 roots are accounted for. They're all real, but only one of them is rational. The other 2 are irrational. Do you remember last year when you talked about irrational roots and imaginary roots? Do you remember the fact that they always come in pairs of 2? Like, it's impossible to have 1 imaginary root, and it's impossible to have 1 irrational root. They come in pairs of 2 because that's just how the quadratic formula works. It gives you pairs of 2. Yes? So if you were to have, if we were to have cheated on this one and we were to plug in x to the third minus 5x squared, you would have seen 3 roots, I think, but only one of them would have been a rational number. If you were to trace those and figure it out, 1 is the only rational answer. Okie doke. Any questions? So now your big takeaway is the rational zero theorem and how to kind of use those p's over q's to come up with your list of possibilities. Okay, here's your homework. I'm giving you the whole situation. Whatever is happening right there. Is there a field trip or something today? No?
See Brock scored yesterday?
Did I see he scored?
Yeah, and like at the end of a period, his hockey team faced St. Joe's in a shootout.